This is AP Calculus Lesson 2-10. I'm recording this a day in advance because the seniors are going on a trip. So, hello seniors, I miss you. All right, so yeah, make sure that your date is on it. So it's going to be 9/25/19, even though I'm recording on the 24th. Today's lesson is the quotient rule. Our objective is to use the quotient rule. So very similar to 2-9 where it's just the product rule, you're just learning about the quotient rule. So there are 4 types of quotients. There's one with a number on the top and the bottom, or constant on the top and the bottom if you would prefer that term. You have a quotient where you have a variable on the top and no variable on the bottom, just a number on the bottom. You have the quotient, or you can think of it as a fraction, as a number on the top and a variable on the bottom. And then sometimes you have a variable on the top and a variable on the bottom. So another word for quotient, if you haven't figured it out already, is fraction. Fraction. So what is the derivative of 3/4? And you need to pause the video now and answer this on your own. So pause it. All right, so you've unpaused the video. It's just a number. This is just a constant. The derivative of a constant is always 0. All right, again, pause the video after I read this one. D dx, the derivative with respect to x of negative 5x divided by 4. What is that? Pause the video, try it out. All right, you've unpaused the video. Another way to write this is the derivative with respect to x of negative 5/4 and then x out to the side. And when I do the derivative like that, I know that the derivative of x to the power of 1, the 1's going to come down in front like the power rule. 1 times negative 5/4 is negative 5/4. Negative 5/4. And then this would be x to the power of, it goes down from 1 to 0, and anything to the power of 0 is just 1, so that guy is eliminated, and it's just negative 5/4. All right, let's come down here to number 3. Go ahead and try taking the derivative with respect to x of this fraction. Go ahead and pause me now. All right, so you have unpaused me. This one you need to play with it because I don't like fractions. As a general rule of thumb, fractions are hard, so I need to change this into the derivative with respect to x of 3 times e to the negative x, and then I can divide this all by 2, which is the same thing as putting the 2 right there. I could have written that all over 2, or just putting the 2 there is fine as well. Now that I have no fraction, I guess that fraction is fine, it's just a coefficient. Now that I have no fraction with a variable, I can take the derivative. So I'm going to take the coefficient, that's still out here, 3/2. And then derivative of e house is e house. So it's just e to the negative x. And don't forget your dinner. Always get your dinner. So inner is just negative x, which means dinner, the derivative of that inner is negative 1. So multiply this all by negative 1. And then I can simplify that really quickly. That's going to be negative 3/2 e to the negative x. And there is my answer there. And I guess I could have boxed my answer up here as well. There it is. All right, so this one, number 4. Take the derivative of 2x minus 1 over natural log of x. So I'm not even going to let you try this because you should be confused. You should be saying, I don't know how to do that. Maybe you might be thinking, oh, maybe you can bring this natural log up here and change it to the negative 1. Yeah, you could, but even if you did that, you'd be dealing with, and don't write this down, you would be dealing with the derivative with respect to x of 2x minus 1, all of that times another function, natural log of x, all of that to the power of negative 1, and it's going to be product rule. And you have negative powers, so it's going to be hard. You could do it with product rule, but generally speaking, the answer here, if I undo a bunch of times, is use the quotient rule. I cannot spell quotient rule. There it is. Exclamation point. I have to use the quotient rule because I have a variable in the top, a variable in the bottom, therefore I have a function on the top and a function on the bottom. So let's learn the quotient rule. So use the quotient rule when you have a fraction with a on the top and a on the bottom. You can either say variable here on the top and variable on the bottom, or you could say function on the top and function on the bottom. That's a little bit better. I'm going to say function on the top and a function on the bottom. I know that's not technically correct because technically y equals 3 is a function. 3 is a constant function, but that's kind of just like a coefficient in this case, so I'm assuming that it's not a constant function when I'm writing this out. All right, so here is the rule. if I'm taking the derivative of a function on the top and a function on the bottom, this is, and this is again the textbook definition of the quotient rule. It's kind of painful. This is the one that we're going to memorize down here. So this is the one you really need to know and have down. Here it is. It's going to be g of x times f prime of x. And you might be thinking, oh, that kind of looks familiar. It's kind of looking like product rule. Minus, though, not plus. And then it's going to be f of x times g prime of x. And then it's going to be a fraction. All of that all over g of x in parentheses. That thing is going to be squared. So there it is. Have it copied down, and I'm moving on to the rule that I want you to memorize. So if I have high and low, I think of the high function as being on the top. It's higher than the other one, and then the low function is lower than the other one's on the bottom. I could say top and bottom here, I guess. That might make more sense. But this one sounds cooler. So this one is going to be, well, let's see. What do we do first? We did g of x, that's the bottom, so low. Low, and then we took the derivative of f of x, so the derivative of fx, derivative of high, so d high. Low d high minus, and then f of x is on the top, so that's high. High, and then the derivative of the bottom, derivative of low, is d low. And then all of that is going to be divided by low squared, so you can think of this as, let me make that fraction a little bit better too. You can think of that as low squared, or if you want to think of it, it's low. So again, you need to practice saying this. The derivative of high over low is low d high minus high d low all over low. So low d high, you start low, and I think it was Kaylin and Sophia that were like, oh, you start low, but then you end on this high, like you end better. So you start low. You always have to have subtraction sign, which is different from product rule. It's kind of like the reverse of the product rule. And don't ever forget your low on the bottom. A note here, I'll write this here, for the bottom is don't FOIL this. Don't FOIL. Don't multiply this out. Just leave it as whatever squared. I mean, you could multiply it out, but that will never help you. And I mean, you might see an AP test where they do multiply that out, but generally speaking, they're not going to do that. So let's go ahead and do an example. Pause the video now. Try this one out using the low d high minus high d low all over low. Try this right now. Pause it. All right, so you've unpaused the video. Here we go. Low is 3x plus 1. 3x plus 1. I just did low. Good. Now I have to do the derivative of high, the derivative of the top. So the derivative of e house is e house, so times e house. But don't forget your dinner times -1. Inner was the power for e house is -x, so dinner is -1. All right, we just did low d high. Now I'm going to copy down the minus sign, and now I have to do the rest. High is e to the -x, e to the -x. Can't write my x, there it is. And then I'm going to multiply that by the derivative of the low. So multiply this by the derivative of the low. The derivative of 3x plus 1 is just 3. And then that's all going to be divided by low, or just 3x plus 1, that quantity squared. And then you do need to simplify this because you always need to simplify for my class. So I'm going to have a negative, and I guess I can distribute that negative into this one. I'm going to get a let's see, how much room I get. I'm going to work over here. Negative 3x minus 1. This all times e to the -x. Should you be simplifying by writing that divided by e to the x? I mean, it's fine if you want to write it this way. I know that some people are like, well, Mr. Sindel, you shouldn't have negative powers. This should be over e to the x. That's, I mean, you can write it that way or the other way. I'm fine with either way, unless I explicitly say in the instructions to not have any negative powers. So that thing is going to be subtracting this guy, so minus, and it's going to be 3 over e to the x. I'm just being consistent. You could have just left it 3e to the -x. And that whole thing, we'll put, I don't need square brackets. I could just do a giant fraction here, and that's all over 3x. Ooh, it doesn't like writing at the bottom of the page. 3x plus 1 quantity squared. We did run out of room there, but there it is. And then box my final answer. So you have your example, you have your homework, and that's the end of the notes. Make sure that you don't do your summary right now. Do your summary later in the car if you're doing this in the car. Yeah, and that concludes the lesson.